location of my muffler, and by introducing a little bit more heat in the engine bay by my exhaust system, I figured it made sense to make sure I do a fan shroud. So this is me diving into it. Like just about everybody else, before you jump into doing anything with sheet metal, usually you make some cardboard or paper templates, and this is no different here. There's a lot of going back and forth with this, back and forth to the car and making trims and trimming paper and trimming cardboard. But eventually I got something in paper form that fit, and I was able to start transferring this to the sheet metal itself to start making my cuts. Things a little easier. I made a cardboard template of the radiator itself, and then I could use that as a kind of a building point as opposed to going back and forth between the radiator that's in the car and my work surface here. But I traced out the location of the fan. Again, I had to, I had to bias the fan as high as I could on the radiator to get it to clear things like the muffler, and also to give me the greatest angle to make sure I get it kind of optimize the amount of airflow going through the radiator. Once I got the angles right, or what I felt was right, I transferred that to some semi-thick craft paper. I keep a couple of rolls on hand in my shop for doing things just like this. And so this allows me to put bends where I know they need to go. The paper bends a lot crisper than does the cardboard, so it's better material to work with. And from there, I can actually transfer this to the aluminum that I'm going to be cutting. And you'll notice that I denote any of the bends in dashed lines and cuts in straight lines. So that kind of helps me keep track of what I'm doing with the workpiece after the template's removed. That has definitely saved me quite a bit of trashed material. When it comes to cutting this thin material, especially aluminum, you've got some options, and I would love a shear. That's the one thing I don't have in my shop and would like to get in the future. But really, when it comes down to it, the cleanest, not in process but in end result, the cleanest approach is to use the angle grinder. At least that I found. I use a steel straight edge, and I use that to kind of make sure my lines and my cuts are all clean. The downside is there's a fair amount of cleanup afterwards, both in just cleaning the mess up in the shop because it sprays stuff everywhere, but it also leaves a rough edge that you need to go back and file smooth. Here I'm starting the bending process. My poor Harbor Freight brake here, it's felt the brunt of living on the seacoast. I had it in a place that it would sweat a little bit, and it rusted pretty bad, but it still works like a champ. Really inexpensive tool, kind of invaluable in all of this process. But I'm getting the bends kind of straight. I'm using my cardboard template as a guide. I then do need to go back later on and kind of do some hand adjustment. But for the most part, this puts the nice, crisp, clean bends where I need them to be, and allows assembly and ultimately the riveting to go much smoother. these small bends on either end. I still had to go kind of old school on it. I clamped it between a couple of metal pieces and bent it to shape. Now on to cutting the fan opening. As you see, this fought me a bit. My router bit that I used was a bit dull, so the aluminum kept gumming up in the leading cutting edge, and I kept having to clean it out. But I muscled my way through it. Word to the wise: use a very sharp bit when you're cutting aluminum, especially thin wall aluminum like this, so it can clear the flutes. Otherwise, it does get gummed up and slows everything down. So I put off the radiator shroud as long as I could, the fan shroud. That wasn't something I was looking forward to doing. And I'm not great with sheet metal. You know, I lack a lot of the tools and a lot of the know-how. And, you know, obviously it would have been far easier to purchase one, but something like a Breeze unit, those frankly look a lot better than what I put together, and I suspect they're better built as well. I know welded seams are going to be superior to the riveted seams I had to do. But I didn't have a choice. I had to make my own. There isn't an off-the-shelf option because of where my muffler is. I needed to tilt the fan kind of at a different angle and bias the fan far higher up on the radiator just to get everything cleared, give everything enough clearance. I'm also thinking from a maintenance standpoint later on down the road, so I can access some of these parts if I need to change them out. So needed to make my own. So this is where we are. I'll give you a little walk around here. Well, this is where I landed, and you can see it's kind of a different shape than maybe some of the other ones you've seen here. It's got a different angle to it. Actually, let me walk over to the other side. I think you can see it a little easier. way better. So you can see the angle of the fan is significantly different than that of the radiator, and again, that's just to give myself clearance. And you know, I could have actually made the fan parallel to the radiator and just make kind of a shallow box, but you know, when you think about airflow, you want to give the fan access to as much of that radiator as you can, and by placing the fan right next to the fins that you're trying to draw air across, some of the radiating surface, the fins on the on the outer kind of portion of the radiator would just lay for the most part stagnant. There'd be kind of a stagnant column of air in there. So that's why I angled it out to create a greater volume of air between the fan and the radiator. Again, to just give the fan access to more of the radiator. But this is done, and I'm happy with it, and I'm looking forward to moving on to the next project, and very happy to cross this one off my list. This thing's been staring at me for a while now, and a couple little nicks on my fingers, as I always get when I'm doing sheet metal work, but beyond that, no worse for the wear. So on to the next project. Hey, so quick add-on to the end of this video here. I just wanted to report that I ran the motor for a little bit, got it up to temperature, and without a doubt, it runs a little cooler at idle with this fan shroud. And you can tell as that fan's pulling through, you feel it pulling through the entire part of the radiator, so as opposed to before just pulling through the center. So definitely happy with the performance of that. I know just idling it in the garage here is not a great test of it, but hey, I saw about a 5 to 8 degree difference in about the same temperature scenario. So good news there. But that's not why I'm keeping you here. I've had a few questions, a few emails about my e-motorcycle. I think it's popped up in the back part of my video a few times. I also on my YouTube channel have a I have a YouTube channel. That's kind of funny. But I do have a little quick video on this. It's just a slideshow, but I wanted to talk real quickly about this. So this was my project 2 years ago, built it from scratch. I designed it on legitimately on a napkin kind of thing, and then moved that to a CAD program, and this is how it ended up. This is, what I use. My wife and I use this for scooting around town, going out to dinner, grabbing ice cream, that kind of stuff in the summertime. Top speed's about 40 miles an hour. It's a big bike. It's about as long as a Harley Davidson. Those are 30-inch diameter wheels to kind of put things into perspective for you. It's like I said, it's electric. It has a 13-horse motor, which is way too much motor for this. Luckily, you can program it in the electronics, and I was able to dial it down a little bit, but way too much. I should have gone with a motor about half that size. Batteries are up underneath the footrest there. I get about 25 to 30 miles range. Like I said, it's just around town. And it gets to 40 mile an hour really quickly. No lack of power there. The design really was, I wanted kind of something that looked old, like a vintage Harley, but wanted to throw in a little bit of, I don't know, California surf vibe to it, which is where the wooden sections came from the seat and the footboard there, kind of a little surfboard kind of look to it. There's no suspension. I rely on the big spongy tires, which is also why I've capped it at 40 miles an hour. Without suspension, it just wouldn't be safe after that. I use downhill mountain biking parts for the disc brakes, front and rear. It also has electronic regenerative braking. So I can drive quite a bit of brake force as soon as I hit the brake pedal. So as soon as I hit this brake pedal here, that activates the electronic brake, the regenerative braking, which helps slow the bike down as well as the front and rear disc brakes.
Electronics are under the seat flips up. That's where the electronics are. But so yeah, chain drive, super fun. I can't tell you how much time I spend on this in the summertime. This is one of my joys, ripping around town silently. So there you have it. I just wanted to do a quick walk around on that. Hope I didn't bore you on this group of Cobra videos, but I did get quite a few emails just kind of asking questions about it. So figured I'd show you guys. Hope you enjoyed it. Have a good one.